Alright, in this problem you have x cubed minus 1 over x minus 1. It says simplify the rational expression and then list any restrictions on the domain. I have x cubed minus 1. You should be counting how many terms do you have? I have 2 terms. Is it a sum or difference? Can I just add a 0x? I cannot. So I have the sum and difference of cubes. This is the problem where you're going to do your SOAP. Same, opposite, always positive. If I take the cube root here, the formula is a, b, a squared, ab, b squared. And then the SOAP is same, so it's going to be minus O for opposite of negative, which is plus, and then always positive. Your A value is x. Your B value is 1. A is x. So x squared. A times b is going to be x times 1, which is just 1x, or just x. And your b value is 1 squared, so that would be just 1. So this is how you would factor the numerator. So that was step number 1. Can I factor anything? Step number 2, can I cancel anything, class? Yes or no? Now, what I'm canceling here, class, that becomes our what? Yesterday we learned that that's called the removable whole. Partner A tell partner B, what do you put inside the orange box? Isaac, what do you put in the orange box? Echo? Yeah, what you cancel, you're setting it equal to 0. Isaac, how do you solve that? Correct, and you get what? There's going to be a removable whole or a discontinuity at x equals 1. Now, go ahead and put a box around what you did not cancel. Now, you might be tempted to say that it is a fraction, right? You can always put a 1 here. But if you put a 1 here, it's not a variable, which means that you're not going to do step number 3. You're not doing a step number 3 because there's no variable there. You can't set the denominator not equal to 0. This problem has no vertical asymptote because there's nothing down here. Let's go ahead and graph it. Put your finger on the y-intercept. Class, which function family is this one? Linear, quadratic, or exponential? Quadratic because of the power of 2. So I know my graph's going to look something like this. Well, let me draw the removable whole first at x equals 1. Remember, this orange line that I'm drawing is not a vertical asymptote. But I know when I draw my graph, at that point on the orange, this is where my removable whole is. What does it mean? Any point on the pink graph is defined. It's a solution. But once you hit the undefined whole, it's undefined. Because if you put in 1 there, 1 minus 1 is 0. Anything divided by 0, we learned, is undefined. Okay? So that's question number 7.